close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. See the horizon, turn us to thousands, and we'll grow in number, fueled by them. To see the horizon, turn us to thousands, and on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And we'll go, through the wastelands, walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Show any fear. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. I've been all around the globe, trying to protect your soul.
Alright, I just thought of, I'm looking so bad because of the sunshine, but never mind. I just thought of one thing. Why not just simply read it together when I'm actually going through it? I'm not really watching any video to learn the things. I'm just simply going through the stuff related to WebRTC, and also let's simply read it together. Why not? So the takeaway can be from this that a WebRTC offer is your browser's initial proposal for a communication deal written as structured SDP data. So ultimately SDP is just kind of a data format that actually contains the data and all. It's called an offer because it kicks off a negotiation. Your browser is effectively saying, here's what I am capable of doing, would you like to connect this way? The other peers reviews the offer, decides what to accept or modify, and then replies with an answer. Only after that handshake do both sides actually starting sending audio, video or data streams. So next time you see pc.offer create in your code, think less about employment offers and more about connection diplomacy. Your browser extending a digital handshake saying, let's talk, here what I can do. Okay, let's simply get rid of this. Overall, these are the things that this is the takeaway that I actually need to have in my notes. Again, I will be keeping them because it's gonna be confusing in future. I will forget some things, like how is the overall flow goes. So I will have to just keep all these things in mind. Let's continue. There was one more thing if I'm not wrong, and that was a session description, and also I had to know more about that. So let's simply copy it from here. I will just simply be copying the text and let's have session descriptions over here. Let's get another headline TST, that's gonna be better, and that's gonna be about session descriptions. So it's better to know about all these things really well before actually getting started. Ultimately theory should be done in the best way possible, right? And then I can just simply go ahead with other things as well. So this is what I've got about session description. So what is a session description? It's not like I have no idea about them, but it's better to just simply go through the written text as well. So what is the session description? Think of a session description as a detailed plan or agreement between two devices like computers or smartphones that want to communicate. This plan includes information about how they will share audio and video, such as which formats they can use, codecs, and how they will connect. As simple as that. Ultimately, description will contain the information regarding how they can just simply connect. As simple as that. There are two types of descriptions, local and versus remote session descriptions. Local session description, this is the plan created by your device. It tells the other device what you can receive and what formats you support. Maybe it could be codecs. For example, your device can handle both MP3 and WAV audio formats. Your local session description will include this information. So ultimately, the kind of data that you can actually receive, it just contains all the information. It sends all the information to the next device, remote device, and then remote device can actually know about it. Remote session description, this is the plan from the other device. It tells your device what device can send, what the device can send and what formats it supports. If the other device only sends MP3 audio, your device needs to know that, so it can adjust accordingly. Okay. For a WebRTC connection to be successfully established, both local description and remote description properties must be set appropriately. Without setting both properties, the peers would lack the necessary information to establish a connection, making it possible for them to communicate effectively. As simple as that. I hope it does make sense, and once it is done, then I will be going ahead. So kind of I'm keeping them together so that in future if I get stuck, I can just simply go through them quickly and get the things done. By the way, this particular thing, ultimately session related stuff, is almost done. So let's move to the next one if I have some more things to just simply go through. Yeah, let's read about Eastern servers. Just recently I learnt about them, so why not just simply have a look at them over here, and once that is done, then I will be going ahead. Just recently I just learnt about Eastern servers. Even I created my notes as well, but at the end of the day, too much. Let's keep the things here, exactly the content that I've got, and let's simply start going through that. So more about Eastern. The protocol used by Eastern servers is defined by RFC 5389. There's a lot, don't worry about these protocols. Let's simply focus on what it does actually as at the end of the day. So it uses a simple request response mechanism where clients send binding requests to the server. Binding request in the sense it contains everything, like related to your on-prem, like related to your device and all. So where clients send a binding request to the server, which then replies with their binding request, in the sense when the request goes there, then the server will return, ultimately Eastern server will return the response. At that time it will be binding both the things, like it will be returning your private IP address and public IP address, private port number and public port number, and all these things. So it uses a simple request response mechanism where clients send a binding request to the server, which then replies with their public IP address port information. This process can also include additional attributes like the type of net being used. There are several publicly available Eastern servers that developers can use during testing and development without needing to set up their own infrastructure. For example, Google's public Eastern server is gonna be at this, is widely used in many WebRTC applications and all. Let's go. There is a fun fact again. When establishing a WebRTC connection, both peers generate ICE candidates, that is right, which includes a potential connection endpoints derived from your various sources like local IP addresses via Eastern or the relayed address via turn. The process of gathering these candidates is called ICE, and it involves trying out different combinations until a successful connection is established. But who am I kidding? You already know all of this, don't you? Okay, this is great, but ultimately what happens is that as soon as you create the offer, once the offer is created, the request will be sent to the ultimately this is what I'm talking about. As soon as over here the offer is created, where am I creating the offer? This is where I'm creating the offer. So as soon as you create the offer, ultimately local description actually gets sent. Apart from this particular thing, this ICE candidate gets triggered, and when this particular ICE candidate gets triggered, a request sent to the Eastern server sends to the response, and all the response you will get inside event.object.candidate. So these candidates are created, and these candidates do contain the value of the Eastern servers and all. So if I actually show you right now, if I reload the page, if I click on this, as soon as I would click on this, offer will be created. Once the offer is created, even before that I will be getting the, what will I get before even offer is created? Just a sec. Inside this, first of all, what will happen? So first of all, okay, these are the configuration related stuff I have. I'm creating my peer connection over here. Once the peer connection is ready, this negotiation will not run. First of all, offer will be created, and then this particular thing is gonna run. So ultimately I will be getting the information about my tracks. So I will get track got added, and then I will be apart from this particular thing, then I will get the status, ultimately the report. Once I got the report, and even here once I have added the tracks, then my offer will be created. Once my offer gets created over here, so this particular log will be printed, and after that offer will be set to the description as well. But as soon as offer gets created, this particular ICE candidate gets triggered, and when this gets triggered, so I will be logging the ICE candidates. I mean received ICE candidates. It's just gonna be like I'm receiving these ICE candidates because of ICE gathering process. ICE gathering process simply gathers all the possible candidates, and then the best candidate is going to be used. Having said that, when this particular thing is happening, the gathering process is happening, at that time a request goes to the Eastern server, and from there it just simply gets the public address as well. Let me show you it in action. So if I click on this, I've got so many things over here. So first of all, I got track was added. Yeah, of course we did that. After that we are getting this report that we printed, and after that we are simply saying that offer got created. Once the offer got created, let's even check how many things are there inside the offer. So inside the offer you will actually get many things in the sense actually many things, and in here you are getting candidates as well. So kind of, let me have a look at the candidates. Am I getting the candidates here? Candidates, it turns out there are no candidates yet, but they are gonna be created very soon. So yeah, there are no candidates right now, but there should be candidates, shouldn't there be? Okay, candidates are gonna be after ICE received. So once you have received the ICE candidates, then they are gonna be available. So these are the received ICE connection, and they simply contain the address, and they simply contain the candidate as well. Candidate contains the information got from the Eastern server. So over here you have many things. Ultimately over here you have if you just simply have a look at this, so candidate and 192.34 host generation. Okay, this does not contain that, sorry for that. So this is the candidate. Ultimately this candidate does not have the information returned by Eastern server, so that is why things are not shown here. Let's check out the next one. Over here, this is the type host. Ultimately it did not get returned from the Eastern server, that is why type is host. Over here type is host, so here you don't really need to worry about that. Over here type is host again, so again you can skip this. Let's check this one out. Over here type is srflx, that means it got returned from the Eastern server side, and again the URL of the Eastern server is here. That simply means you will be getting more options over here. Getting more options in the sense, even here you are getting your public address. So this is your public address, this is your public port, and this is your private address, and this is your private port. It's just like that. So all these things are handled by Eastern servers, and the component type is RTP. And ports, again this is the port, public port I'm talking about, this is the public address, and these are the related ones are gonna be the private ones. So related address means public IP, private IP address, and this is gonna be private port. Again private port and public port, they can be the same as well, if they are the same, depends, but IP address is definitely gonna be changing. And that's it. There is going to be one more, and these two are returned. And again the candidate with a higher priority, so this is the priority number that they have. The candidate with higher priority number will be used for the connection. And apart from this particular thing, host it is from host side, it is from host side, and it is also from host side. And at the end I'm getting ICE received null. ICE received null means the gathering process is done, and then at the end of the day when the candidates are ready, it simply returns null response, so that the browser can, or the the browser can know that okay, or you can know that ICE gathering process is done, you have got your candidates and that. So first of all it will render all the candidates, and once all the candidates are found and ready, and after that it will just simply return null, as simple as that. So this thing is also done almost, at least for now. Let's get rid of this thing. So many lines are here, let me close some of them. Okay, not close, I had to remove them. Turns out there are many things that I have, so kind of a whole book is getting created while learning. Okay, what is the next thing that I can just simply go through right now? So I have gone through Eastern servers right now. Let's simply remove this particular thing from here as well. And then the next one is gonna be don't overcomplicate during ICE negotiation signaling server client. Don't overcomplicate your code. During ICE negotiation, your code has two primary responsibilities: signaling server client side, except ICE candidates received from one peer and transmits them to the other peer via signaling connection. When on ICE candidate handler is triggered, that's fine. Client side receives the ICE candidate's message from the signaling server, specifically when a new ICE candidate message arrives, and then pass these candidates to a browser's ICE agent by calling RTCP peer connection ICE candidate. So that's all there is to it. Your code does not need to worry about it. Okay, let's simply copy and paste, and just I'm gonna be keeping it in my notes. So ultimately this is gonna be over here. Ultimately a connection is gonna be ready. Connection in the sense, let's keep it inside Eastern servers itself, like, or I'm gonna be EH3, but it's gonna be this connection. Let's keep it here. Connection related information I'm gonna be having over here. It's better to have it this way. Let's change the color of it to green, and let's simply go through the things. So again, I'm gonna be removing this. So during ICE negotiation, your code has two primary responsibilities: signaling server accept ICE candidates received from one peer and transmit them to the other peer via signaling, that's right, connection when on ICE candidate handler is triggered. On ICE candidate handler is triggered. So when this handler gets triggered, when the offer gets ready. So whenever your offer is ready, and when the offer gets ready, by default offer is not ready. By default offer gets ready whenever something changes in the peer connection, right? So whenever something changes in the peer connection, offer is going to be ready, offer is going to be created, and as soon as the offer is going to be created, this on ICE candidate is going to be triggered. And when this is triggered, so ultimately at that time accept ICE candidates received from one peer and transmits them to the other peer. Alright everybody, got some work right now. That means I will have to go, but before going, let's get this thing done. So signaling server, there is going to be a signaling server that will just get the job of signaling. So what it does, it accepts the candidates received from one peer. So ultimately your local peer that you have on your own device, the peer connection of course you made, and you got lots of candidates, and the candidate with higher priority is going to be selected. So ultimately signaling server accepts that, and after that transmits them to the other peer. Again, WebSocket is gonna be used there, maybe, probably, I'm not even sure, but mostly if you wanna signal somebody, so WebSocket is used, right? So transmit them to the other peer via signaling connection when on ICE candidate handler is triggered. So ultimately whenever this particular handler is triggered, I have to start my server, and then server will get the candidate and then simply transmit the candidate to the other peer. Client side receives ICE candidate's message from a signaling server, of course that's right. Specifically when a new ICE candidate message arrives. So whenever the message arrives on the other side, it will just trigger the ICE candidate, it will trigger the signaling server and then pass these candidates to a browser's ICE agent by calling RTCP peer connection add ICE candidate. So ultimately new ICE candidates are gonna be added. That's all to it. Already your code does not need to worry itself with the details within the HTTP session description protocol. I always try to adhere to the KISS principle, keep it simple and stupid. Okay, bottom line, avoid complicating matters until you have a solid understanding of how everything works. Unless you have a solid understanding, do not complicate them because it's gonna be confusing. Alrighty, by the way, this is it. I have some work, and that work will take around half an hour to get done. After that, I will be back and I will continue learning. Ultimately, main focus is gonna be on this WebRTC. Let's get it done because I have to work on the clone of WhatsApp. That is a huge project, literally a huge one, and if I want to get that done, then I have to know about it as well. So that's why I'm just learning it as soon as possible. I'll be back and continue from here on. Until then, take care and see you.